Have a nice day, students. Now we'll see measures of deviation, measures of dispersion. First measure is called as a standard deviation. Standard deviation. There are different measures: mean deviation, standard deviation, etc. First of all, we'll write the variance. Variance sigma square is equal to sigma x square by n for discrete distribution. For discrete distribution minus x bar square. Actually, it is written as sigma x minus x bar square bracket square by n, and after all simplification we can prove that it is equal to sigma x square by n minus x bar square, etc. For discrete frequency distribution, standard deviation is written as sigma equal to root of sigma x square by n minus x bar square, and you are familiar with x bar, etc. For continuous distribution, if you write ui equal to mi minus a by h, just we have seen in measures of central tendency divided by h, then u bar is equal to sigma summation fi ui by n, then x bar is equal to a plus u bar into h. Just we have seen the formula like that. Next is, then we can say standard deviation square is equal to h square into bracket sigma fi ui square by n minus u bar square, or standard deviation, here it is called as variance, and standard deviation is equal to h square root of sigma fi ui square by n minus u bar square. It is formula for standard deviation. And there are two more deviations, measures of dispersions are like that, are these. First is, before going to that, coefficient of covariation, coefficient of variation is CV equal to sigma divided by x bar into 100, as because it is multiplied by 100, it is written in percentage. Lower is the coefficient of variation, more is the data stable. Next is mean square deviation. Mean square deviation. Mean square deviation is written as a square equal to 1 by n sigma fi into xi minus a bracket square, where a may be mean, median, mode, whatever it may be, mean, median and mode, whatever it may be. Third is defined as mean deviation. MD equal to sigma fi into modulus of xi minus a by n. Actually, you can see that this square is taken to avoid this modulus or plus minus sign. Otherwise, my minus and plus gives you bad results, you may say. This is the mean deviation formula. Next is combined standard deviation. As we have seen, standard deviation. Suppose we have given n1, n2, n3, etc. Mean of the data x1 bar, x2 bar, x3 bar, etc. Standard deviations sigma 1, sigma 2, sigma 3, etc. Then x bar is equal to n1 x1 bar plus n2 x2 bar, just we have seen in previous lecture, n3 x3 bar, which we have seen in previous lecture, n1 plus n2 plus n3 is the combined mean of the data. It is mean of the data, combined mean of the data, and then we can write combined standard deviation. For that we require di is equal to x1 bar minus x bar, d1 equal to d2 equal to x2 bar minus x bar, d3 equal to x3 bar minus x bar, etc. Then combined standard deviation is given by sigma equal to square root of n1 into sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square plus and so on, divided by n1 plus n2 plus and so on. This is the formula for standard deviation, combined standard deviation. We will see examples in with the help of green board. Thank you. We will see continuously.